But more importantly, I also get access to to opportunities within the community, opportunities to engage with explorers globally in different events, like I just did last week, at the National Geographic Explorers Festival, which is an annual event in Washington, D.C., where explorers come from all over the world and we are in one place for a week. We enjoy a range of workshops and symposium. And I was speaking at the Explorers Fest. And for me to speak at the Explorers Fest, I had to be trained, on how to speak to such a diverse audience and how to speak with authority and so well. So there's that training that comes with this opportunity, right? But also I get access to resources. So for example, the National Geographic community has a resource where you can get equipment loaned to you, different types of equipment, different types of cameras, for example, underwater cameras, which I can just complete a request online and they will ship it to me anywhere in the world. Imagine that, on loan for however period I want, of course, within reason. I mean, not 3 years, for example, but maybe 3 months, right, for a particular project. So there's that. But also the fact that I can now receive mapping resources to make maps of different kinds with very high resolution data, which many geographers or remote sensing specialists might know.
The Roots of the Science podcast with your girl, Anne with an E. Hello, everyone, and welcome back to another episode of the Root of the Science podcast. I'm your girl, Anne with an E. If you're watching on YouTube, remember to hit the subscribe button and remember to share this podcast wide. If you're listening on audio, remember to hit follow and leave us a comment in the comment box on what you think of this particular episode. So, at the Cradle of Humankind in South Africa, it holds fossils and artifacts that reveal how early humans evolved, migrated, and adapted. By analyzing bones, tools, and environmental data, scientists trace physical changes, cognitive developments, and the rise of complex behaviors. These findings help explain the roots of human diversity and how ancient innovations shaped survival. Today, in this episode, we are joined by Dr. Tebogo Makhubela, a geologist, a geochemist, and the newly named National Geographic Explorer. He is based in South Africa, and his work focuses on dating ancient fossils to uncover the story of our human ancestors. He is the field director and also the PI with the Rising Star program and has played a key role in some of the discoveries within the Cradle of Humankind. In this episode, Tebogo walks us through the beginning, how he got into the field of geology. He talks us through about some of the work and the research that is involved in. And most importantly, he also tells us about this National Geographic Explorer Award that he is a recipient and what that means, as well as the impact. Tune in to all of this and so much more. Let's go. Hi, Tebogo. Welcome to the show.
Hi, Anne. Thank you. Thank you very much for having me. It is a pleasure to be with the Root of Science.
Yes, I mean, we spoke off air that we've been seeing each other on social medias, but it's really amazing that we get to have this conversation one-on-one and at a very auspicious and very special occasion. Congratulations on your award once again.
Well, thank you very much. It is a very, prestigious honor, the award I've just received. I'm one of the very few Wayfinder awardees in South Africa, but also globally, of course. So it is a prestigious honor that I appreciate very much. Thank you.
Sure. So we're going to get more into that conversation just now. But for the purpose of this intro, I think for our guests who might not know you, could you just briefly introduce yourself? Who is Tebogo? Where are you from? Where are you based? And just what do you actually do?
Sure. Well, Tebogo Makhubela is a Soweto born and raised academic, now working at the University of Johannesburg In fact, UJ has been my home ever since first year.
Oh, wow.
So after completing my schooling in the secondary school, Vwani Secondary School in Soweto, I went to UJ for my first year in geology. And I just never left, So I did undergraduate, honors, master's, PhD there. I became a member of staff in the Department of Geology. And in addition to being a geologist at UJ, I am now also a National Geographic Explorer.
Lovely. I love that last line. So, Tebogo, let's take it back. You just said you're
Sure.
born and raised in Soweto. How does a young Soweto boy get into geology? Like, is this something that you always knew, or was it by accident? Like, take us to that starting point.
Right. Very good question. And, so I stumbled onto geology when I was in grade 11.
Mm-hmm.
And, I was flirting with it. I really was.
Okay.
But of course, I did not want to appreciate it and commit to it because my background, which you might relate to, and many will, I know, is that, for us as a first generation university goer, what you study when you get to the university matters. And of course, our parents and our families will say, hey, you must do, either things like accounting or engineering, like the famous ones that they know, that they've seen other people making it in those fields, because as a first-time university goer, you need to be a success for your family, you need to change things for your family. And so there was that aspect to it, whereby I did not want to admit that I'm attracted, to this field of science that no one knows about. But I've discovered it was only in January 2009 when now it was time to register. I had no bursary at all for geology, but I had 3 bursaries. All 3 were for engineering. Oh. Mining engineering, chemical engineering, all 3 bursaries. But I was talking to a friend of mine whom we had just completed matric together, and we had both done so well. And she told me that she has decided she is going to study mine surveying, despite what everyone else is saying.
Yeah.
And she gave me the courage to want to go for geology. And I did, without any financial backing. And so my first year was very tough from the aspect that I had no funding. I was funded by NSFAS, which I'm grateful for. And it worked out because I did well. And then second year, I got a bursary to fund me. So it was a strange field of science. I knew nothing about it, but I was very attracted to it. And once I started it, I can tell you now from the very first lecture, cosmology and the birth of Earth, I knew I was home right there and then.
What a beautiful story, Tebogo. That's amazing. It literally gave me goosebumps because now when we're speaking about this now, like, because you won that award and you started with saying that people didn't even know what geology was, but now people know National Geographic. They're like, now we know. So it's like, it's pretty amazing that like you started and you're so brave to do so. Not many are. And I hope maybe somebody else who's listening to this, especially a young person, is like, okay, let me be as brave as Tebogo, because you never know where you'll end up, right?
True. Yes. Yes, good point, because I, as someone who has been working in the university now for a few years, over a decade, over the years, I've seen many students who start studying something else and then end up either in geology, or they start with geology. After the first semester, they end up elsewhere, in a different field. And one of them, we've become very good friends. I was still a tutor when she started geology first year. And after the first semester, she changed. She went and she did human resources. And now she's having a thriving career, in human capital management. And she enjoys that because she loves working with people and empowering people from a different perspective, more intimately and personally, but she had to, of course, spend the first semester and then spend second semester of that first year not doing anything because she had to change courses, But yes, so I was lucky that I was brave enough to go for exactly what I wanted, and it worked out for me.
Yes, lovely, amazing. So let's go back to this award. What does the award actually mean to you, especially on at a personal level and even at a professional level? And maybe while you're answering that, could you maybe just give us an overview of what this award actually is for those who are like, okay, you keep talking about this award, but what is
Sure.
it?
Well, and the Wayfinder Award means the world to me, and I don't say that lightly. It really means the world because the Wayfinder Award, firstly, has made me become a National Geographic Explorer, which means I have now joined a global community of explorers from all parts of life and all parts of the world. And by that, I mean some of the islands which you probably have never heard of, There are explorers who are based in Polynesian islands, Cook Islands, for example. The end of the world where, when we think about it, to get there probably takes like 3 to 4 days just to get there.
Wow.
And I'm now in the same community with them. And I now enjoy a lot of resources and opportunities with them. Award-winning explorers, might I add, people who have won Oscars, mind you.
Wow.
Because the National Geographic community is not just for scientists, but it also includes storytellers, some of the best photographers in the world, some of the best filmmakers in the world, some of the best leaders in conservation are National Geographic explorers. They are now my colleague as part of this global community. Together with them, we have access to funding that I could only dream of. The award on its own already comes with a $50,000 prize to me that I can use, to further my work. Wow. But in addition to that, already I have the opportunity to apply for an additional $100,000 right now this year, which means there's a great chance at the end of this year I would have accumulated $150,000. I don't have to tell you how much that is in rands. It goes a long way, So that means my work is not going to have any further challenges as far as things that need funding. I'll be able to fund more graduate students to work with. I'll be able to discover undergraduate students and help them throughout the university progress, undergraduate and then early postgrad into postgrad. Those, of course, who are interested in becoming scientists, But more importantly, I also get access to opportunities within the community. Opportunities to engage with explorers globally in different events, like I just did last week, at the National Geographic Explorers Festival, which is an annual event in Washington, D.C., where explorers come from all over the world and we are in one place for a week. We enjoy a range of workshops and symposium. And I was speaking at the Explorers Fest. And for me to speak at the Explorers Fest, I had to be trained, on how to speak to such a diverse audience and how to speak with authority and so well. So there's that training that comes with this opportunity, right? But also I get access to resources. So for example, the National Geographic community has a resource where you can get equipment loaned to you, different types of equipment, different types of cameras, for example, underwater cameras, which I can just complete a request online and they will ship it to me anywhere in the world. Imagine that, on loan for however period I want, of course, within reason. I mean, not 3 years, for example, but maybe 3 months, right, for a particular project. So there's that. But also the fact that I can now receive mapping resources to make maps of different kinds with very high resolution data, which many geographers or remote sensing specialists might know. The basic data that you need to use to make a map, I get access to that now, easily. And I can get people to work with on making different types of maps. And these are just examples of the different types of resources that I now have access to, So if my institution cannot afford to pay, for example, for ArcGIS with Esri, I don't have to worry. I already get that through National Geographic Explorers community.
Wow.
So these are examples of what it means to be awarded the Wayfinder, but to also become a National Geographic Explorer.
What a rich and full package, personally and also very professionally. And I love the fact that it's not only going to empower you, but what you mentioned, that you can empower the up and coming scientists from first year, because we all know that research needs funding, and the main cause and the main case, especially for many of us in the developing country, is the issue of funding. And I'm so happy to hear that because you won this award and because you are exposed to all of these very many wonderful resources, more young Tebogos, and the beautiful thing is that Tebogo can be boy or girl, can follow in your footsteps. That's amazing. So let's talk more about your work that got you this honor. So for some of us who are unfamiliar with your field, please explain what geochronology is and how it helps us understand human evolution.
Sure. So geochronology is a branch of geology. Geology being the study of the earth, the earth's process, and the products of the earth's processes, So things like the rocks and the minerals. And I don't have to talk about the importance of the rocks and the minerals. I think we all know that, because the rocks, give us the soil, and the soil give us the food we eat, And then the minerals, they give us the platinum, the gold, the diamonds. Well, you're a lady, I don't have to tell you about the diamond, So that's the earth and its processes. But then geochronology is the science of telling the time with regards to the earth's age and the earth's processes and the earth's products, So, for example, when a particular volcano erupted, we can determine that time, even when it happened before the time of humans on Earth, say maybe 1 million years ago or 5 million years ago. Geochronology helps us determine the time. Or when a particular rock was formed, that's when geochronology comes in, And how geochronology works, we use isotopes. These isotopes are like twins or triplets, for example, for elements.
Okay.
Let me use carbon as an example. Carbon has 3 isotopes. 2 of those isotopes are like twins. So we have carbon-12 and carbon-13. They're naturally occurring. So they are formed naturally on Earth. And they are formed in different quantities. So what we refer to as abundances, And because of those abundances, we are able to compare them relative to each other and understand certain aspects or characteristics of different products or processes, with regards to plants, and animals, because carbon is mainly found in organic materials, which plants are, right? But then there is a third isotope of carbon, which is carbon-14. It is not naturally occurring. It is formed on the Earth's planet, or Earth's surface rather, by a process called cosmogenic production, whereby we have cosmic rays that are coming into the Earth's atmosphere from either the sun, which are the solar cosmic rays, or from the outside our solar system, which are the galactic cosmic rays. So when they enter our atmosphere, they emit atoms of other elements, all sorts of elements, nitrogen, for example, in the atmosphere, but also on the Earth's surface, in rocks, but also in plants, right? And then they impact those atoms and they facilitate the formation of a new isotope. In this case, you have nitrogen being converted into carbon-14, right? And then you form this commonly known isotope of carbon known as radiocarbon, because it is radioactive. It is not stable like carbon-12 and carbon-13. Over time, it decays and changes form spontaneously, and interestingly, it changes form back into nitrogen-14.
Oh, okay.
And so, because of that radioactive characteristic it has, you know, because we know how long it takes for a carbon-14 atom to convert to a nitrogen-14 atom, right? It has a half-life of 5,300 years. Because of that half-life, we are able to then use that to tell time. Wow. What I mean is that if we take a material, say a piece of wood, because wood has carbon, and then we look at, okay, it has so much carbon-12, it has so much carbon-13, and it has so much carbon-14, right? Depending on the amount of carbon-14, we are able to say, okay, for this wood to have this amount of carbon-14, when would it have been formed? Well, because we know the rate of formation of carbon-14, you know, in wood on the Earth's surface, we will say, okay, it has, argument's sake, 1 million atoms of carbon-14. To form 1 million atoms at a rate of, and I'm making it up now, at a rate of, well, 10 atoms per year. How much time would it take to form 1 million? We'd get a certain number in years, and we say, okay, this is the age of this piece of wood, right? And that's how we are able to date trees, for example. And then we can relate that to time of when it formed. And that's how geochronology works in a sort of like simplified manner using carbon-14 and radiocarbon dating, so-called carbon-14 dating. But of course, I use different types of cosmogenic nuclides in my case. I use beryllium-10 and aluminum-26. They are both not formed on the Earth by natural processes. They are formed by cosmic rays. And so when I find them, I know they were formed by this process. And so I can use them to tell the age of things that are on the surface, but also things that have been buried, you know. And so I can tell the age of buried fossils indirectly, you know, to say, okay, well, since these fossils are buried with these sediments, and these sediments have got quartz, which is the common rock-forming mineral that was formed, say, for argument's sake, 1.5 million years ago. Therefore, these fossils are this age.
Wow. That is so fascinating. And it's quite amazing how all these different factors, the sun, the soil, are able to really tell us a story of time and how things have evolved. That's super interesting. I get why you stayed. This is interesting.
I was just saying that is the beauty of science, you know. There is the chemistry aspect of it, there is the physics aspect of it, of course, the mathematics, and then the earth science, the geology. But of course, the biology of it, you know, because to understand how carbon-14 is formed in plants, you need to understand the processes of those plants, you know, and that is science.
Yes. It's all coming together as one. So in your work, you are the field director for the Rising Star program, which explores the cradle of humankind right here in South Africa. So given this context of what you've explained, what your work that you've done, I wanted to know what has been some of the most important moments or rather discoveries that you've actually been on. I'm sure there's been some really exciting things. Tell us about that part.
Sure, yes. So more specifically, I am the principal investigator. So I'm the director of the geology, right? So not the overall science, because for our program, which is the Rising, right now it's still called the Rising Star program, Professor Lee Berger is sort of the overall director of that program. Because, you know, there is the archaeology aspect for it, there is the paleoanthropology, you know, I'm leading the geology aspect of it in all its form, you know. And so I joined this program about 12 years ago when I was still a PhD student. And over the years, I have then advanced to become the Makulu boss for the geology, you know, the PI for the geology.
Yes.
In all the sites where we work. And so some of my contributions to all the discoveries goes back all the way to the beginning. But more recently, you know, we've made discoveries related to evidence of potential mortuary practices by Homo naledi as a species, evidence related to other hominid fossils, which we have not yet announced, in other related sites within the cradle, but also studies of evidence that help us understand the world when Homo naledi was living in. And by that, I mean the paleoclimate, so ancient of the past, and the environment and ecology of the past. I'm talking over the past 300,000 years, because there is one site, which is a tufa site, tufa being a rock that is formed by fresh water on the Earth's surface. And I have a PhD student who just completed, and we were studying this tufa deposit, and we've discovered that this tufa site is 299,000 years old.
Wow.
And this is a major find.
Wow.
Because tufa, it consists of a lot of plants, that are incorporated in it and fossilized. I mean, excellent preservation of plants, whereby we are able to study plants in the rock record and compare with plants that are still on the landscape today. Wow. To see if those plants are still on the landscape or not, which is important for understanding the changes that have happened. But more importantly, the inorganic fraction, the calcium carbonate fraction of tufa, tells us a lot about the stable carbon and oxygen isotope, which tell us what were the atmospheric conditions, what was the temperature, 300,000 years ago, 240,000 years ago, 200,000 years ago, right? And the importance of this is the fact that in the time period I've just mentioned, Homo naledi was living. We know this. But in addition, our own species, Homo sapiens, was emerging on the African continent. In North Africa, we've got fossils of Homo sapiens, archaic Homo sapiens. And here in Southern Africa, in places like Blombos, Border Cave and all that, we've got evidence of Homo sapiens doing different forms of archaeological activities, and now we'll be able to understand clearly the atmospheric conditions under which they were doing it, when there was a drought, when it was very wet, and how that could have affected their lives, So these are some of the evidences. So yeah.
I am just mind blown. Sorry, I'm still processing that you can find all of this information from rocks. It literally blows my mind. So, okay, I don't want to say it's a stupid question, but I have a question. So when you look at when you have some of these findings, let's say you look at the types of temperatures, you look at maybe some of these natural occurring things like drought, etc. Does this maybe then help us paint a picture of some of the things that we can expect with potential climate change, etc.? Could you, I'm assuming it should. So could you explain a little bit further for us?
Yes, happy to. So very good question. Let me start there. So here's one thing you need to know about the Earth. The processes we observe today are not new. They are not starting today.
Okay.
They have been happening in the entire history of Earth. And that history, we know it to be 4,500 million years old. The Earth is 4.5 billion years, if you want me to put it using different units, right? And so there's a lot of these processes that have been recurring, and we often see that there is a sequence to these processes or events, right? Whereby one event leads to another, And so the rocks are a very good memory. They're a memory book of Earth, because rocks have been formed throughout the history of Earth. So they've been recording different events. We know this. That's why we are able to find the fossils of animals and hominids, our ancestors, that have lived, 2 million years ago, 3 million years ago. We find them in the rocks because the rocks have taken a snapshot of that time and preserved it, all right? So we find all sorts of information about the earth in rocks. And so by studying the right rocks, we are able to see, okay, this event happened maybe 3 times over the last million years, and this event was associated with this and this and that, So for example, we are able to see that, okay, drought periods were maybe preceded by a particular climate or succeeded by a particular climate. And that then helps us understand how we can predict the future, because we are predicting the future based on a sequence of historical events, that we have enough information about, not just in terms of time, but spatially as well in terms of place, to say, okay, in this place, this is what happened in this scenario. Therefore, in the same place, when we see that happening again, we can easily understand what to expect. Yes. And that's how it helps us with that.
That is so fascinating and such important information. This also just makes me think then that I think it's important for us as scientists to work together, because let's say, for example, I'm in crops, right, to do agriculture, and I'm working a lot in terms of drought and the expectations of the impacts of drought currently. But now speaking to you and understanding this chronology of time, and it makes us more aware of some of these patterns that we are seeing, and maybe can also help us better advise people on how we can better adapt, given that we have this information. So such phenomenal work. Brilliant. I'm learning a lot. It makes me so excited. And I hope even as some of our listeners are also like, wow, this is pretty interesting. Tebogo, as we are chatting and as we're wrapping up, there's something that has to be said. You are an African, and you work in the space that in the past was maybe not so predominantly filled with people who are African and who look like you and I. So you said that you've been doing this for the past 12 years, and even before that when you started as a first-year student. So what role do you think an African scientist like yourself plays in reshaping this narrative of this field that you're actually in?
Yeah, that's another brilliant question. You are right. The field of geology, for example, at a research level was not transformed in the past, in the South African context. It was largely dominated, by non-natives, but also more specifically, the field of geochemistry and geochronology in the context of human evolution was also not transformed, in the sense that a lot of the science was done by scientists from abroad who would come in, do what is known as parachute science, and then they would sample, do a field work for like a week or 2 or a month, and then leave with fossils and do all the work abroad, Whereas nowadays, scientists like myself, like my colleague, fellow National Geographic Explorer, Dr. Kinelwe Molopiane, who is an archaeologist, what we are now doing is that we are based in South Africa, in South African institutions. We do field work throughout the whole year, and we mentor and educate students. We inspire them to become part of the human evolution sciences, so that's how we are changing the field. But more importantly, we are involved in participating in the greater understanding of, firstly, understanding the rich diversity and preservation of fossils right in our backyard, So we are taking initiative, to lead a science of understanding what the region where we live has been blessed with. So there's that aspect. But also we are contributing by adding African voices to, the discipline, the science of human evolution, which is very important because, well, it is a very important voice, to add to the discourse of understanding where all humanity comes from, especially because all humanity started in Africa, before the spread of our species to globally. So it plays a very important role in not just today, but also securing future scientists to continue the work as well.
Absolutely. And another important thing is that you are a visible role model. I told you off air that I saw you on the Super Scientist card. And just as a little backstory, I do a lot of work with young students at schools, and I give away some of those cards. So it's really great that now somebody can see you, and
Yes.
they can identify and even work with you, like from seeing you on a card at like primary school or high school level. They can come to University of Joburg and work with Dr. Tebogo, and and you're part of this. So I think, like you rightfully said, it's such an important voice that needs to be in the space. And thank you for being in this space, and thank you for trusting yourself and being brave enough to enter into this field, because I'm sure it wasn't easy. Like you said, you didn't know what you were doing, what you were getting yourself into. But here you are right now, you're mentoring other people, and because of the accolades that you're getting now, you're also going to be able to lift people. So I commend you, and I'm so grateful that you are part of this conversation, and you're part of this really, really amazing work, because more of us and more Africans need to be in this space. So yeah, kudos to you, Tebogo. It's a pleasure having this conversation, and knowing that there are people like yourself and your colleagues who are part of this field. So
Well, thank you very much, Jen.
you're welcome. So, final question, as we're speaking about empowering young people and empowering young scientists. So, what advice would you give to someone who aspires to get into this space, but they don't quite know how to, so that they can be where you are, hopefully one day?
Sure. Well, that's a very important and very good question. So, the first advice I would give is that fall in love with the science for its beauty, because science is very empowering. It is very, very fulfilling. I say that because, science helps you understand the world you live in, from the basic things. So, for example, I am able to understand a lot of things that happen in the kitchen just because of my very good grounding in chemistry. Because there's a lot of chemistry to that, but also physics, to understand why certain things cook faster than others. It has to do with the chemistry and the physics of it, even though I'm not practicing in those fields, it helps me as a person, empowers me at a personal level, right? But as a geologist, understanding the world that I live in from, a climatic perspective, or a geographic or global perspective, it does so much for me. But beyond that, science has given us everything we know today. All of science has contributed to the life we enjoy today and will continue to do so. And therefore, we need more scientists. And those scientists need to be curious and passionate about learning more about the earth, but about life forms, life processes, and all that. And the best way to get into it is, of course, while still at school, you make sure that you commit to understanding the basics that are taught at high school physical sciences, and then the mathematics. That is the starting point. And once you narrow that down, then investigate what type of science you like to see yourself specialize in, because then it will be easier to start seeking out role models like myself for those who are interested in learning more about the earth or working with the earth processes. Then they can start looking up people like myself and start looking up institutions, that offer opportunities and additional information. And so it makes it easier to have a clear mind and approach to the science that you are mostly interested in, and how to succeed once you're there, without any particular blind spots that might catch you later on. Those are my advices to young people who are interested in science.
Such great advice, and I hope somebody really does take it up, and like they said, hopefully they can be like, I heard you on the Root of the Science podcast and I'm here.
I hope so too.
Or even later on they'll say, maybe we heard this episode, I'm now a National Geographer because of that wonderful conversation with Tebogo. Or it takes that one little seed, right?
Oh my goodness. Imagine that. I mean, there's nothing I would like to see like more South African based national geographers, National Geographic Explorers more specifically.
Yes,
so, yes.
yes. And I mean, it starts right here, knowing that one person or two people got there. So it makes it easier because the path has been identified. So
Yes.
Tebogo, I had such a great time chatting with you today, learning about the work that you do. And once again, congratulations on your award. And I'm so excited for the type of work that you're going to do, but most importantly, the impact that it's going to have in this space, but also on the other people who are going to be empowered by all the resources that you're able to now have.
Well, thank you very much, and I appreciate that. And you've put it so well. Impact, that is at the core of what we do, and also the National Geographic community, impact and positive change. We are all about that, and I'm happy now that I've got a platform that will help me, spread the positive impact and change. And I do hope to reach as many young people as possible and show that it is possible. You just have to believe in your dreams and your goals.
Absolutely. To everybody else who's tuned into this episode, thank you once again for listening to another episode of the Root of the Science podcast. Until next time, goodbye.
Goodbye.